I'm going to show you how to shatter your game object in Unity using some open source scripts. In this demo scene I'll show off what it looks like and some shaders I developed to give some depth to your object after you break it. Just for fun. I won't go over how to do that in this tutorial, but maybe in a future tutorial. And then just to show off that this algorithm works at scale, you can see you can break a large object into really tiny pieces. Alright, to get started, I have a mostly empty project with two open source scripts. We have MeshCut and MeshMaker. These scripts will perform the initial cut, and that's what we'll start with, and then we'll change that script so that it acts more as an algorithm and we'll create a break on our object. So I'm going to add a plane to act as our floor, and then I'll add an object to break, which will make a cube. And then I'll just go ahead and clone this cube and kind of make it look like a knife just for the visual representation. And then on our cube, I'm going to go ahead and tag it as something, and I have a tag here called Shatter, and this will basically be the identifier for our script to be able to know what's allowed to be cut and what's not. And then on our knife over here, I'm going to add our script called Cut. And then I'm going to make sure everything's got a rigid body. And then we will go and edit our script. Alright, so you can remove everything inside here. You can add one public variable called inside material, which is a material. And this is going to be what renders on the inside of an object after you cut or break it. And then we're going to have an on collision enter. And then we're going to set it so that when you hit an object with the tag of shatter, in my case, then we're going to execute the function called cut object, which will make a private void cut object, which will accept a game object that we want to cut, and we'll just call it obj object. So up here we'll do an if statement, if collision dot game object dot tag dot contains shatter, then we will call our function and insert our collision.gameObject. Inside here, all we have to do is call our open source scripts by doing this. We'll create a list or an array of game objects called pieces. We'll set that equal to mesh manipulation dot meshcut dot cut, and then we give it the object we want to cut, the position of our knife, and the face we want to orient our plane to do the calculation for a cut. So this will be different depending on which object you're using. I'm hoping that transform.right will give the right results for me, but we might have to come back and change this one. And then for the last one, you put in the inside material. Then after that, you loop through each piece and you add any components that you want to give your piece. So for instance, we want to add a rigid body and a mesh collider so that it has the physics that our original game object does. And then for our rigid body, we actually want to reset the center of mass, because otherwise it retains the original center of mass of the original object. And we'll set this to convex. After that, we want to make sure we destroy the original object, otherwise all the pieces go flying. And that is it. That should work. Back in our game scene, we can make sure our cut script has a material assigned to it. We can press play and then cause a collision, and then we should see our cube get sliced in half. There we go. Ta-da! So now what we can do is come back to our knife, and then we can remove our cut script and then replace it with a shatter script, which is going to look largely the same, but we're going to loop through it in a particular pattern that will actually shatter our cube. Now we can go into our Shatter script. So for our Shatter script, I'm mostly going to copy and paste what we did for our cut script. And then the first thing we're going to do is add some new variables. So we're going to have a public float load time. I'll get to that, what that means later. And then I'll have a public float generations. So the way this is going to work is we're going to keep cutting subsequent objects over and over again, and we're dubbing this generation. So if you want two generations, the original object is generation 0, and then once you cut it, you have two new objects. Those two objects exist on generation 1, and then once you cut those objects, those 4 objects will exist on generation 2. So if you have 2 generations, it stops there, you know. So we can change the name of our function to say shatter instead of cut, just to be a little bit more clear. And then we're also going to add to this function our generations as a parameter. We'll just call it gen, and then we'll add it here. And then the next thing I'm going to do, what are we doing here? Oh, I see. We'll keep generations an integer. That makes more sense. I'm going to make, instead of void, we're going to call this an IEnumerator. And so in order to avoid losing frames while we do this calculation, we're going to not do the entire calculation and run tens of thousands of lines of code all in one frame. So we use an IEnumerator to give a pause before we do the next generation of cuts. So we're going to yield return new, wait 4 seconds, and then we're going to specify a random range of our load time and our load time times 2. And the reason we do that, and there's plenty of other ways to do this that might be more efficient, but the thought behind this is that we're trying to keep each subsequent object out of sync with each other. So when we spawn 4 objects on generation 2, all 4 of these objects are disjointed on separate frames now. So that way they each kind of have their own frame to themselves to perform their subsequent cuts. There are better ways to do this. You could do this on, we could just say yield return null, and then that should just, wait 1 frame, and that's kind of a way to do it, but this is the way I kind of like for gigantic calculations. And then it also makes when you break the object, it kind of looks a little bit more fluid, like pieces kind of chip away a little bit more naturally. And then what we're going to change when we call our mesh manipulation scripts, instead of the transform position, we're actually going to get the center of the collider of the object that we're cutting. So we'll do that by calling the object.getComponent, collider. And then we're going to get bounds.center. And then for our angle, we're going to try to change this based on the generation we're on. So I'm going to create a helper function for this, and we're going to call it getAngle. And then we're going to insert the object and then the number generation that we're on, and we'll perform that calculation. So down here we'll create a new private vector3 getAngle GameObject object and integer gen. And you can do this a number of ways. I do this because it looks kind of the most natural, but there are probably easier ways and better ways that you might find that you could do this, but I'll just show you mine. We'll start with defining a quaternion called Q, and we'll set this to quaternion.Euler random.range. We'll say -40 to 40, and then we'll say random. We're pretty much going to do the exact same thing for the X, Y, and Z, so we'll just copy and paste. So that'll rotate our plane in a random direction on both the X, Y, and Z axes by some, by a specified range. If you go for a full range of randomness, there's the potential that you end up getting 2 identical cuts somewhere, so you end up generating a piece so small that Unity can't compute it. So you get an error and nothing actually gets spawned. It's just kind of, it also can make things look ugly and messy. So specifying a smaller range is better, and then multiplying it by a face that will loop through for every 3 generations we go through, and we'll do that here. So an array of vector 3's called faces, we'll put in our object.transform.forward, object.transform.right, and our object.transform.up. And then what we want to return is going to be our quaternion times faces at position gen modulo 3. So then that doesn't return an error anymore, so we're good there. So that's all we have to do there. So to make sure we continue looping through, we want to, at the end of when we add our components to our new piece, we're gonna put that piece back through this function again. So if gen is more than 0, we will start coroutine our function, the piece that we want to continue breaking, and then our generation -1, and you need to make sure you put that in, otherwise you'll crash your game. Well, I guess because it's an enumerator, you won't crash your game, but eventually it'll lag your game so bad it basically will crash. So you need to decrement our generation each time so that eventually it hits 0 and won't start another coroutine. Which reminds me, up here we need to make this a coroutine too. So start coroutine, and that's looking pretty good. I don't think I'm forgetting anything, so we can go see if that works. So now finally we can test our script. We can add a material. Let's set a load time to something really small, like 0.15 sounds good, and we'll just do 2 generations. Press play, cause a collision, and then we should see our game object is now shattered. There you go. Let me know what you think.